Welcome back, everybody. Today we got a real short question here and then some review, and I'm going to come back again with another lesson. So today question we have here is, why does Waikiki Beach, beautiful Waikiki Beach, warm up faster in the daytime than the water does? And you can see it there. It says warms fast over the sand, warms slowly over the water. You've probably experienced something like this, where the beach is really warm and the water's really cool. So I want you to think about this question. We're going to come back to it, but right now I want to do a little bit of review. I think you're a little bit rusty on this stuff still. So the three methods of heat transfer. We learned about conduction through solids, convection through, and if you remember right, it was liquids or gases, because they can flow, like the radiator on the right-hand side. And on the left, it's heating up the air, which is circulating around the room. And then radiation, which is the transfer of heat through, and if you think right, it's solids, liquids, gases, and even the vacuum of outer space, or radiant heat. And all three methods right there. We have the person experiencing the radiation sideways from the fire, off to the side. The person whose hands are directly above the fire is feeling probably some radiation, but definitely convection of that rising warm air. And the person who's holding the iron stick or the iron rod here has to have a glove on, or else their hands will get burned. All three methods. And there they are again. Radiation off to the sides. Convection is occurring within the pot. Conduction, the hand touching the handle of the pot. Solid contact. Okay, some more review. Types of change of state. Melting and solidification. These are opposites of each other. And we learned about melting before, was changing from a state from a solid to liquid. So, you can see the ice, obviously they're melting. And solidification or freezing goes backwards from liquid to solid. Evaporation or vaporization, changing state from liquid to vapor. You can see it, the water vaporizing off the surface of the car. And condensation, the opposite, changing state from vapor to liquid. Some other phase changes we used in the weather unit. Sublimation occurs when water goes directly from the solid phase straight to vapor, skipping the liquid phase. Now, this isn't water here. This is carbon dioxide, dry ice, in that photograph. But sublimation does occur when, like a snowbank, for instance, will slowly sublimate throughout the winter and get smaller just from that state change in state. And going backwards from sublimation, we have deposition, changing state from a vapor, like water vapor, for instance, in the atmosphere, directly to solid, which are these ice crystals in those cirrus clouds. So a quick review of phase change again. Name the process that occurs in each of the following slides. We're going to go through a bunch. Tell me whether the heat must be added or removed to have this phase change occur. And of course they are melting and freezing, evaporating or condensing, sublimating or depositing. So ice to liquid water. What would happen there? If you said melting, you're right. And you have to add heat for melting to occur. Liquid water to water vapor. If you said evaporation, you're right, or vaporization, and you have to add heat once again. Water vapor to liquid, now we're condensing, and you have to remove heat for that. Liquid water to ice, now you're freezing, and once again you have to remove heat. Ice directly to water vapor, skipping the liquid phase. Sublimation is the correct answer. And you have to add heat. Water vapor to ice, skipping the liquid phase. This is like those cirrus clouds. Deposition. And you have to remove heat for that process to occur. Okay, in this particular one we have freezing, sublimating, melting, condensing, depositing, that's frost, evaporating, sublimating, condensing, evaporating, it's a hot cup of tea, deposition, it's frost on the window. And this chart kind of sums it all up. In order to go from a solid to water, you have to melt, water to vapor, you have to evaporate, going backwards, condense, from vapor back to water, and then to go from water to ice, you have to freeze. Going from left to right, you're always adding heat, going across this way. And going from right to left, you're always removing heat, going this way. Now this was pretty much an 8th grade topic, but because you tend to forget this stuff, it's important to know for the last unit and for this unit. And that's the quick lesson we have here. We're going to meet back up in a little bit for another lesson.